back actually. When I was preparing for this talk, I was thinking what to tell you. And then I just decided to talk about something that I'm really, really interested in right now. It's slightly related to what I do during my day job, but also it's about why I'm doing it. And when I was listening to all these talks in the morning, some of you do astrophysics, some of you do particle physics, you do accelerators, you build stuff. And you're really good experts of how to do that. And when you do a PhD, that's what you learn. But the question is that I'm asking here is why you do it and why you do exactly what you do. And my point will be is that if we can answer that question, which I can't, but if we can, then, okay. So if we can answer the question why you do exactly what you're doing, that will also help us to integrate AI into society, because that yeah, it works. It just works. Okay, because that's the big issue today. There are two worlds and they clash, and there is no interface between the two worlds. Okay, so let me just start to say what I mean by meaning crisis. I will show you with respect to CDS. So if you don't understand the word, it's a pretty much used word in a certain corner of the internet. People talk about this, but I will explain it through an example. So let's keep it in a suspense for now, but I will explain what I mean by value, because I certainly don't want to say that AI doesn't have value. AI has huge value. You saw it in protein folding when you saw it in cosmology. What I want to say, the valuelessness of AI, by the valuelessness of AI, is that value is extrinsic to AI. It's a baby of the scientific world, and value is in a certain sense also intrinsic of science. And I will also explain you what I mean by that. I don't want to offend you or provoke you. There's a very specific technical sense in which I mean that the value is science. So what I mean by value and meaning, I use them as a synonym, is a guide to tell us how to act, what to do, not about what is, but what to do. So the outline is I will have a couple of examples about recent controversial examples of AI. Then my meaning crisis, the two words and their collision in the CDS. Then I will give you one slide of John Vervaake's 4 P's of knowing. John Vervaeke is a cognitive scientist. They call it the third generation cognitive science. And this is an integrative metacognition framework. And I will argue that it is a good framework to actually talk about things. And at the end, I will talk a little bit of techniques, but it will be very light. And it's about mainly the foundational role of reinforcement learning, not necessarily the technical role of it in this context. So let me start with a survey. First example will be about self-driving cars and Tesla. So would you like that the self-driving cars drive as humans, or do you want that they obey all the vehicle code? First, who agrees that there is an or here? That these are not the same. The law, the rules. So who would like Tesla to drive like humans? And who would like that Tesla obey all the vehicle code? Okay, that's interesting. Because my argument will be that this second one, it will kill traffic. But so let's see the actual examples. So in the US, a lot of times you have a crossing where there are 4 stops. And protocol is that everybody stops and whoever stopped first can leave first. It's not necessarily a very efficient protocol, but it works and it avoids crashes, right? So when there's an like this and there is a car in sight and no pedestrian in sight, very few people actually stop. You just roll through at a slow speed. And this is what Tesla implemented in the self-driving car. They had they have 3 levels of assertiveness in driving, and on the top level, the most assertive style of driving, they roll through the stop sign if those conditions are satisfied at 5 miles an hour. And this was a new feature, so it became public. It was a big scandal, and the traffic agency in the US said, probably tautology, that it increases the risk of crash, of course. And so Tesla withdrew this, and now Tesla cars stop at every stop sign. Okay. So what's the problem here? The problem is that the code is a propositional set of things that we should do, and then there is the way we drive. And when I drive, I might be in a hurry and I might have some feelings of shameness because I miss a meeting, or I'm angry at somebody who crossed me, and so I'm more aggressive. Actually, I can also see the other cars, how they behave, so I can infer their state of mind. And there's a lot of value comparisons and value arguments in my mind that unconsciously go through. I decide whether I roll through or at the stop sign. And these things are really hard to codify. So that's the point in this example, that you have this propositional statements about how the world is, and maybe even how it should be, the ideal, that's the code. And then there is the real world where we act according to a complicated set of values, of which the rules is one. Okay, the second example, this is even more, it's more subtle, but I found it fascinating. So this is an article from 2017 by Rodney Brooks, like a popular paper on criticizing image classifiers, which at that time were state of the art and really amazing. Okay, so this 2 paragraphs is about, let's say, an image classifier that recognizes a scene on the photo that people are playing frisbee. And his argument is that if I ask you what's in the photo and you say people play frisbee, I can also assume that you can answer a lot of other questions. Like, what is the shape of the frisbee? It's a disc, right? How many persons can play frisbee? Can a 3-month-old person play frisbee? And can a person eat a frisbee? Which is also a question. And so his argument is that time, 2017, is that computers cannot answer to those questions, right? Then we are in 2020, 21, 22, and GPT-3, the big language model, comes out, and transformers. And so then Roy, who's a researcher in machine learning, asked it on Twitter, can somebody please ask these questions to GPT-3? What does it answer? And so Melanie, who's another researcher, did it, like ran it through the GPT-3 prompt with no parameter tuning and no tuning at all. So it's the default. So the answers are amazing. So the criticism in 2017, it's completely off today. But there are these weird questions here, like, can somebody eat a frisbee? The answer is a person can eat a frisbee if they want to, but it's not recommended. Now, follow-up question, why is it not recommended to eat a frisbee? Person should not eat a frisbee because it's made of plastic, which is true, and it could be harmful to their health, which is also probably true. I don't know, but yeah. So what's the problem with this? It's a perfect question. It's a true statement, right? You cannot say that GPT-3 is saying something stupid, or can it? Can you? Because when I asked my 9-year-old stepdaughter about this, can I eat a frisbee? What did she answer? What do you think? It's not food. She looked at me and she said, are you stupid? You know? So it's not that it's true or not true. It's the question is not, it's not, when you say frisbee, it's not food that comes into your network of everything that you know. What comes in mind, it can depend on who you are, but definitely cannot imagine a human, like an identity or a sort of type of human who thinks it's food. Or maybe, but it has to be a very complicated story to make up. You can imagine, maybe if you're really thirsty and there is no other thing around, but there is water and you want to drink, you might be able to drink from a frisbee. And that could be something that I can imagine a situation like that, but eating it, no. You can imagine that it triggers some kind of willingness to bond with a friend or with your kids because you want to play frisbee. If you're a professional ultimate frisbee player, it might be that makes, you know, money for you, and the skills that you developed on the frisbee are really important for several reasons, but you still don't want to eat the frisbee. Okay, so the point what I want to make here is that GPT-3 knows everything that there is to know propositionally because it just read the internet, the full internet. Let's say like a visible proportion of the internet was fed into it. But it lives in a flat world where every, so proposition, it's either true or false. Its only value is its truth value. Its proposition doesn't tell you how important, how salient, how valuable the fact that we state that proposition is. And in this sense, GPT-3 lives in this flat world where every proposition has the same interest for us. Okay, it doesn't know, it cannot know that this question is stupid and just tell us, well, why are you interested in it? Because that would be a more interesting conversation with it than actually telling the truth about the edibility of frisbee. So this concludes my two examples from the AI world, to show you that there is some kind of, even though these methods are super interesting, super useful, and very far ahead in intelligence, there is something that's in there. And so let me just go into my meaning crisis, which was, as David said, I was the director of the Center for Data Science for 5 years. Our mission was to connect sciences to AI. Among others, we were building an organizational management and software framework to put AI into scientific pipelines. And the goal was efficiency, do the process as fast as possible so you can serve as many scientific pipelines as we can. It was very nice. We did about 30 pipelines like that. The software is called RAMP, and we built an organizational framework around it, including what we call the pitching days, where scientists came in and told us their projects. They wanted to work with us, and they explained us where they want to put the AI in the pipeline. The problem was that, so it was very efficient, but our resources were still limited. The question was how to choose between, say, protein folding or astrophysics or particle physics or analytical chemistry or behavioral economics about like 20 different projects. Do you want to recognize Mars craters, or do you want to predict solar storms, or do you want to discover a new particle in a more efficient way in the LHC? Okay, so these were the questions we had to answer. And so what I realized was that my scientific training gave me no tools at all to decide which projects to choose. This was outside of the scientific realm. Okay, and that was my meaning crisis, because I started to question, why do I do what I do, and why am I in a physics lab and not in an economy lab or a social science lab or a health lab? How do I compare those things, and what are the criteria? Okay, we did make up some technical criteria, like, do you have data? Do you know what to do? Do you know how to measure the performance of your pipeline? And those were important, because without them, AI would not work. But on the top of that, like, is it more important to recognize a dosage in an analytical chemistry lab where you administer chemotherapy drugs to people, so to make it more safe? Is it more important than, let's say, recognizing galaxies of the earliest universe on images? So this is where I realized that I lived in two worlds. There's this scientific world where I work, where I'm solving problems. I have a lot of fun with solving problems. And then I go home and I hug my kids, and I'm in this world where I have a body and I have feelings and I have values and I live. And in a certain sense, I realized it's very easy to live in those two worlds for my whole life, because they are so separated. The technical, physical, chemistry, scientific world, and the world which I'm living, right? And here the two just clashed, because I had to answer questions using my value hierarchy, the same value hierarchy that I'm using when I decide to drive through or not at stop sign, to decide what project is more important. There are some other areas where those two words touch. Depends what science you work on. If you work in healthcare, medicine, it's been always the case. And if you just think about how to measure subjective things like pain, or what to do with the placebo effect, you see the problems, right? Those things are sort of like perturbing out of the scientific methodology. You don't know how to measure it because it's subjective. It clashed here in the CDS. And what the point I want to make, it also clashes in AI. Because AI was a fun toy in the 90s when I started. It became even more fun toy in the 2000s and 2010s. But today there are a lot of places where AI is in the society, and it clashes with this value soaked world where we live. Okay, and the problem is that it comes from the scientific world and it has intrinsically no value built in, or does it? So before I'm going to explain a little bit of machine learning, let's see this framework I'm really enjoying listening to and understanding. So John Vervaeke is a cognitive scientist at Toronto University. He has a scientific career in cognitive science. He's what's called a third generation cognitive science, where people realize that cognition is not in the brain, but in the body, in the full body. It's not isolated from the world, but it's in interaction with the world. And it's not isolated from the world in the sense that it's also extended into instruments like accelerators. So we build a lot of instruments to enhance our cognition. So this is in a nutshell, it's what's called third generation cognitive science. And he's one of the figures in it, and especially interesting because he wants to teach it to the public. So he has a 50-hour YouTube lecture called Awakening from the Meaning Crisis, from where I borrowed my title, where he explains this, of course, much more in detail. So here I just want to sketch his framework to be able to talk about where AI is. Oops. So let's start with the bottom level, the propositional. And this is bottom level in the sense that the others will influence it. It's the propositional, where GPT-3 lives, science lives, mostly language lives. It's a set of statements, knowledge which is just a set of statements. They have no notion of value or meaning other than implicitly that they exist. The proposition is either true or false, so it has a truth value. But other than that, it also has a value that somebody said it. Okay, so its value is coming from somewhere else, probably. There was a reason why somebody focused on that particular proposition, and its existence is its value. In AI, this value comes through labels, if you do classification, or the raw data that we give to the machine to learn on. Okay, so value is there, but it's very, very much implicit. The second level is procedural. So that's where the frisbee example comes hand, because it's how to throw a frisbee. So it answers to the question how to do something. It's action oriented. It's a set of skill to do something valuable. So value is still extrinsic, but at least it's explicit because I want to do something to achieve some value. Engineering is there. So when we build stuff, and when you build an accelerator, for example, that's a skill. And the interesting thing is why propositional depends on the procedural is because you cannot propose propositions unless you can do science. And by doing science, for example, you build accelerators. In AI, I would argue reinforcement learning is a good formalism for this level. And that's would be a huge step to use reinforcement learning more in the formalism today than we use. It's very far from the end of the story, but it would be a nice step. The other remark I had here is that even when AI acting exists, the actors are us. So AI is usually like an internet system. And when something happens in the real world, AI acts through us, which is also an interesting thing to think about. Now, the other two are more complicated and we are very far in AI to actually even talk about it. Perspectival way of knowing, he answers to the question, what is it to be like here and now? Like this room, I see the eyes, I behave in a certain way, certain things are salient to me, I notice. I juggle with values. Let's say I really have to pee. I will still hold it because I don't want to, offend you, and it would be shameful if I just pee here. Stuff like that, So there are things that correspond to this sort of value judgments and saliency of what I see. The trouble with this is that it's pre-inferential. So if it could be learned from data, then how would you collect the data for it? It's before data collection, okay? So when we walk into a space, we are somebody, we have an identity, we have a history, we have a cognitive agency. We go in, things become salient for us before we do any inference on them, okay? And this is why I have no idea how to do this in AI today. And the sense it gives is the sense of presence in here and now. And the top of it, have this participatory way to know. What is it like to be me? And it's where Vervaeke calls it knowing by being. So what are the identities and roles I'm assuming, and what I assign to the world? The affordances, that's an important terminology here, that, I have a grabber and this thing is grabbable. Those two conform each other. And this set of affordances are the ones that define what I can know. So without this, without being in the world, you cannot know. And this is how it goes back to that way. So without being a scientist, there is no science. But very bizarrely in science, there's no real space for scientists. In the scientific world, the scientist is an outside agent. Scientist is an outside agent. So when I talk about integration of those two, this is what I'm talking about. And my point is that to integrate AI into society, it's a very similar move that we have to do for AI. We have to integrate the agent, the AI agent, back into society. So just very briefly, because I'm out of time, I would argue that in supervised learning today, value is there, but implicitly through the data, and the leverage on how to inject value into AI is through the data. And the new thing is self-supervised learning. So GPT-3 is basically that. You get rid of even the labels and the categories you want to predict because it's expensive to produce them. My argument is really nice. You can do language models, but you even lose that leverage where categories. What are the categories to predict? We're defining the values that you want to inject in the AI. So it's even harder. The only thing that remains is the data you collect. And the people argue on that actually, because the biases in the data show up in the function that you learned. So data collection is your only leverage. No? Maybe you can change the function artificially, but it's really tough. So in reinforcement learning, value is still external, but at least it's explicit. It has a goal to increase some sort of value. So you can argue about it. And if you can argue about it, you can make it explicit. You can put it into the political process, and you can argue what the value is that the AI agent should maximize. The other nice thing, which again, we need a theory there, but data collection is part of the algorithm. Part of what the algorithm should optimize. And I give you an example from physics. You build simulators to design detectors, right? So on what data do you build a simulator? You would like to build it on the data that will be in the subdomain where the detector will work, but you don't know your detector yet. Have an iteration. You want to focus on the range of the data that you will want to collect, right? So you can imagine that it has an iteration. So the data you collect should correspond to the physics you want to do. Saliency and value arbitration is still outside of the scope. So you still need to decide the value externally. So what I will show you just two little examples that we do. So we work on engineering systems and optimization of engineering systems. So this is just a surrogate engineering system called Acrobot. It's a very easy, I mean, it's not easy, but a simple baseline with two segments, and it has to go up like a gymnast on a rod. And the little arrow is the action it can do, either push your hip forward or backward. And it has to learn the action sequence to do it. So let me run it. What you see here is its believed model of the world, more particularly what's going to happen in the future. It's a model with uncertainty, so it can only also know how long it's reliable in the future, and you see the horizon here. So it's sort of like the brain of the agent. You simulate futures, and then you decide your action based on those simulations. And it's not bad, it's not perfect, but it's not bad. It's certainly learned on a very small data set compared to, let's say, other algorithms. But the most interesting thing with respect to the talk that I wanted to show you is the next one. So this was, the first one was a quite good agent. The next one, we use the same algorithm with a different seed. This happens rarely. The other one was more common, but it happens like 1% of the time. So this agent gets stuck in a world and in a skill that's suboptimal. And we didn't do anything to do it. The goal was still to get up to the top. So it finds this policy where it just stays in the middle, perfect model. So it thinks it knows everything. It collected perfect data for learning that policy, half of the possible reward that it would get. So when you put the data collection in the algorithm, you can get this weird phenomena where the agent collapses and the reality collapses, reality which is represented by the data I collected. Okay, so that's a super interesting world. I would argue it's much closer to the world we live in, and it models our agency. So it's a weird metaphor, but I would say like a drug addiction is like where the world gets smaller and your actions get smaller, and you just go into a hole where you don't have any saliency anymore, you don't have any value anymore, and you don't have any actions anymore other than just to take your daily drug. So as I said, it's a very far metaphor, but it's something like that's happening already in reinforcement learning. And so I will finish just with a conclusion set of slides. The current AI is a baby of the scientific world. Its realm is propositional, and value is only represented implicitly in the data. Reinforcement learning would get us into the procedural realm. It does get us there, where value is explicit and it can interface with the human world. Participatory value realization, saliency detection, value arbitration is still very far from what we can even tell or what we talk about in AI. Embodied engineering systems, we probably need it like the car, because it will have to juggle with different values. And my most important point is probably this, that I think that integrating AI into human society is, in a very deep sense, requires the same move as integrating the scientist into the scientific worldview. And with this, I open for questions.
Thank you very much, Bas, for this very inspiring talk, which paves the way to substituting funding agencies with the reinforcement learning agents. So, questions? Maybe on Zoom first? None? Yes.
Where do you lie on the cherry on the cake arguments?
I had that picture.
The argument is, I think, is it Jan LeCun says that reinforcement learning is a cherry on the cake, and we'll get, you'll fine tune your agent on representations which are learned by some other method, unsupervised or otherwise.
I think cherry is the foundation and the cake is on top of this, according to this framework.
Upside down cake.
But yeah, I actually found a picture of that. I don't have it with me, but I will send it to you. But that said, when I look at Jan LeCun's recent presentations, we are pretty much saying the same thing. It's more a semantic argument than anything, than something fundamental. He's just saying that planning, doing reinforcement learning with planning is just classical control. And what he calls reinforcement learning, it's his argument of the cherry, so the little signal on the top is that for example, games, you have a reward at the very end of the game, so it's very, very, very sparse. It's a very small, tiny information from which you can learn. And he says, let's learn from the infinite data that these agents generate, for example, on reality by their sensors or on their internal reality, in internal states. And let's, for example, learn a world model. Now, I'm saying exactly the same thing. Okay, but I think it's part of reinforcement learning, and I think it's not so simple to move from supervised learning when somebody gives you the data to reinforcement learning where the agent has to gather the data. My other difference is maybe, but it's also subtle, is that classical control, when you learn, when you know the real dynamics of reality, that's one thing. And when you have a model of the world that you learn on data that you collected and decided how to collect, with uncertainties, it raises a lot of other questions. So, but it's very close. Okay, so I wouldn't use that metaphor. I would say the cherry is the value, and everything has to start from that.
So we have time for one more question.
Okay, I hope it's going to be a very quick one. I think it was a very nice talk, and I guess here we enter a bit of a boundary where the distinction between scientific questions and philosophical questions is really overlapping. So I was wondering, do you think there will ever be an opportunity to integrate AI into human society, if thinking this context of the value as being incorporated into the collection of the data? And what I mean is that humans are biased by definition, and we may not even know that we are biased, right? So how can you actually have this value to be, this collection of data to be of such a kind that can make this AI being unbiased? Did you get the question? It was a bit convoluted, but.
So when you say we are biased, you assume that there is something with respect to we are biased, right?
Which we don't know.
And I don't really think that's a good framework to talk in this. We are what we are. Everybody has their own value hierarchy. We live together, so they are sort of like integrated, but they are not the same. But I wouldn't, you know, that's a big philosophical question, whether there is like one big value system that everybody should adhere to, or whether we should learn to live together having different value systems, which is what we decided to do in a democratic political process. So what I would say is more like, let's make AI part of that political process. And so by implicitizing the value, by stating what the values are, and then giving the engineer, let's optimize that value, we can separate these two things in a better way than we do it today, where we have just data with very implicit values inside.
Okay, thanks a lot. We can certainly actually discuss a continued discussion after lunch. But for now, we thank again Balázs.